Hello all, welcome to our channel. So in this video we will talk about one of the most popular sensor used in embedded applications. So this is called a PIR sensor, passive infrared sensor, which is used in most of the applications, general applications. Like example, a simple application we can say is like when a person reaches in front of the door, you might have seen the doors automatically opening up. So that is one simple example where PIR sensor is used. And then another example is like automatic dispensers. All these are some of the examples. So very popular sensor, and there are many articles available outside. So we just wanted to talk here so that we'll just give a brief and interface to one of the microcontroller in the next video, and we'll show you how it works. So just to show you what is inside and how it works. So if you see here, this is the sensor which is the underlying which performs the underlying functionality. The sensor is called pyroelectric sensor. So pyroelectric sensor is a sensor basically which develops a electrical voltage when there is variation in the temperature, whether it will be hot or cold. So if there is a variation in the temperature, then you see some voltage that is out. That's the basic principle on which this PIR sensor, basically the pyroelectric sensor works. So the pyroelectric sensor, so ultimately we can say that it's the temperature change, right? But how it is going to work with the humans, how it is detecting. So basically, if you see the humans, right, humans emit infrared radiation from their body. So which basically when a human passes by through a particular area, example, if a human walks by, there will be a temperature change around those surroundings. So that is what this pyroelectric sensor is going to sense and develop voltage. So this particular sensor is assembled onto this PCB as shown here, and then on top of it there is one lens that is being inserted. So this lens helps, so just to put it in layman terms, helps diversify the sensing. And all the PIR sensors that you see in the market comes with this particular lens. And the board has other components which we will talk here. So all these, while we are talking about the electrical voltage, right? This electrical voltage need to be whatever is generated from the sensor need to be converted into a realistic voltage which can be read by an embedded circuits, right? That's what is the functionality done by this BISS 0001. So this is you can just refer the data sheet of this, which also gives the embedded circuit in this chip. Ultimately, this is the chip which gives us the voltage. We'll be giving supply to this, and this reads the electric output, and it produces the desired output. So if you see here, there are three pins mainly which we interface to the outside. One is ground and supply, which supply it can be 5 to 12 volts. You can check the PIR sensor, some of the ones which can support up to 5 to 20 volts as well. And ultimately you have a regulator on board which converts this into the lower voltage which is supported by PISS 0001. This is the regulator that is here, and then the output comes from this particular pin which is 3.3 volt. These are the basic interfacing pins, and then you see other circuits that are associated required for this regulator, and then this BISS voltage supply, and then other relevant circuitry as per the requirements. And then there will be some potentiometers that you see here, which are in orange color. So ultimately, what we are saying is this sensor is going to sense the temperature, right? That's the ultimate thing. Okay, so now this sense the temperature change basically. So this range of the sensor, so how much range can be covered by the sensor, can be adjusted by this particular potentiometer. So as you vary this potentiometer, the distance up to which the sensor can detect can be changed. And then ultimately what happens is when this sensor senses something, it will produce some output over this output rail, right? That's what we are talking here. So for whether like example, let us assume a human is walking in front of the sensor, and let us understand that initially it is low and then there is a high that is seen on the spin once the detection happens. So for how much time this high remains is determined by this delay time potentiometer, where you can adjust up to 200 seconds. So that's what helps us to maintain the level for a specific time. So for that, one is to adjust the sensitivity, that means the distance up to which this can sense, and second thing is the delay. And then there are three pins here. You can see the yellow jumper on shorting two pins. So this is called the this helps us to understand the trigger option. So what is trigger option is, let us assume a human has walked in front of the sensor and sensor has produced the output. So as long, let us assume human is standing in front of the sensor forever. So in that case, what happens is the sensor first reads that human is there, and then it doesn't reset until human moves away. That is one scenario. And second scenario, even though human is there, after a specific time the sensor can be set such that it resets, and then again it detects, it resets, and again. That's what you see here in the below waveform. So it is just, it has reset, but still the target like the target is the human we are talking here. So the target is still in front of the sensor, and then again it goes up, and then again it retries, goes up. So that's how it is here. It just only a single time is what it does. So there are two options. So you can change your sensor settings to either of these based on what you're intending to do in the end application. And then finally, the ultimate thing is we have to connect this to a microcontroller, right? So this is a simple diagram which shows the 5 volts connected to this, and ultimately this is not an electrical diagram, this is just a representative diagram. So that's why you don't see decoupling caps and all. So just to understand, you give the 5 volts here, and then you give the ground, and then the output 3.3 volts can be connected to the microcontroller. So the TTL level is connected to the microcontroller, and this can be connected to either an interrupt pin or it can be connected to a GPIO. And if you have interrupt enabled, automatically it goes to the ISR and executes. If it's a GPIO, and if you don't have any other complex application, you can just poll the GPIO, and every time when you see that this goes high, you can perform the respective action from this microcontroller. Like example, if you want to control some light bulb, or if you want to control all these, mostly controls the relays, right, through a relay. So the microcontroller will control the relay. Or example, if you are using a simple application hobby project, like lighting up an LED, or enabling a buzzer, anything can be done. So that's again a further topic, which is where the microcontroller controls those things. So that's how the simple circuit can be, PIR sensor can be interfaced to microcontroller. Very, very useful sensor and the most commonly used sensor. So we talk about the temperature sensors or like in the thermostats, whatever, right? Which we commonly see in most of the applications. And this is one of the common sensor used in commercial applications. So if you have tried this already and if you have uh, different observations on this, whether it with respect to sensitivity, delays, and all, please post in the comments and let others learn from your experience. Thanks for watching this video. Please like and subscribe to our channel. Thank you.